January 2026. In a hospital near Kolkata, India, a patient dies of an unknown, rapidly progressing fever. Days later, healthcare workers who treated them fall gravely ill. Over 180 contacts are traced, and a chilling, familiar diagnosis is confirmed: Nipah virus. This isn't an isolated event. This is the latest flare-up of a silent biological war that has raged for over 2 decades in South Asia. A virus that jumps from bats to humans, kills up to 100% of those it infects, and has no cure. With outbreaks in West Bengal for the first time in 19 years, and Kerala facing its 9th outbreak in 8 years, a terrifying pattern is emerging. Nipah is becoming a predictable, seasonal threat. But why here? Why now? And what does the science tell us about stopping a pathogen that turns hospitals into ground zero for contagion? Welcome to Health Inside, Anatomy and Science. Today, we're on the front lines of one of the world's deadliest and most mysterious zoonotic diseases. We will trace the virus's path from bat to human to hospital ward, explain the unique biological reasons for its explosive human-to-human spread, and investigate the cutting-edge, desperate fight to develop a cure before the next outbreak becomes a pandemic. Part 1. The reservoir, the bat, and the spillover. The story begins not in a hospital, but in the treetops. The Indian flying fox, a large fruit bat, is the natural reservoir for Nipah virus. The bats carry the virus without getting sick, shedding it in their urine, saliva, and feces. The primary spillover event to humans happens at the intersection of bat habitat and human activity. In Bangladesh and parts of India, the classic route is the consumption of raw date palm sap. Bats feed on the sap collection pots at night, contaminating the sweet liquid with their secretions. A person drinks the sap the next morning, and the virus has found a new host. But the outbreaks in Kerala point to a more direct route: bats contaminating fruits like mangoes, guavas, which are bitten or partially eaten, which are then consumed by humans or by intermediate hosts like domestic pigs, which can amplify the virus before passing it to people. Deforestation and urbanization are bringing bats and humans into closer, more frequent contact, increasing the odds of a deadly spillover. Part 2. The viral invasion, from fever to fatal encephalitis in 48 hours. Once inside a human host, the Nipah virus is a model of terrifying efficiency. Its glycoprotein, G, binds to ephrin B2-B3 receptors, which are abundant on endothelial cells lining our blood vessels and on neurons in our brain. The clinical timeline is brutally swift. Day 1 to 5, incubation, exposure occurs, the virus silently replicates. Day 5 to 14, prodrome, non-specific symptoms begin: high fever, severe headache, muscle pain, vomiting, sore throat. It feels like a severe flu. Day 6 to 16, acute encephalitis. This is the turning point. The virus crosses the blood-brain barrier. Patients develop dizziness, drowsiness, altered consciousness, and acute respiratory distress. They may experience brainstem dysfunction, leading to coma. Seizures are common. On MRI, the brain shows characteristic multiple small focal lesions. The respiratory catastrophe. Unlike many encephalitis viruses, Nipah also attacks the lungs. It can cause severe atypical pneumonia and acute respiratory distress syndrome, or ARDS, often requiring mechanical ventilation. The case fatality rate is staggering, 40 to 75%, and in some outbreaks it has reached 100%. Survivors are often left with severe neurological sequelae, including personality changes, seizures, and paralysis. Part 3. The superspreader scenario: why hospitals become virus amplifiers. What makes Nipah uniquely dangerous is its propensity for efficient human-to-human transmission, a trait not shared with most other deadly zoonotic viruses, like Ebola in its early stages. This turns healthcare settings into superspreader events. The virus spreads through direct contact with bodily fluids, respiratory droplets, urine, saliva. In the resource-constrained settings of these outbreaks, infection prevention and control can be challenging.
A single undiagnosed patient can infect dozens of healthcare workers and other patients, as seen in the 2001 Siliguri, India outbreak that began in a hospital. The 2026 West Bengal case, where a patient died before diagnosis, perfectly illustrates this nightmare scenario. The first line of defense becomes the first casualty. Part 4. The Recurrence Mystery. Why Kerala and West Bengal? The 2026 outbreaks revealed two patterns. Kerala, the recurrent hotspot. With its 9th outbreak since 2018, Kerala is a tragic case study. Its ecology, lush with fruit orchards and a large bat population, creates a perfect spillover environment. High population density and extensive travel networks then facilitate rapid human-to-human spread. Each outbreak provides the virus with more opportunities to adapt to human transmission. West Bengal, the reemergence. After 19 years of silence, why now? The likely answer is a new, independent spillover from the bat reservoir, possibly due to changes in bat ecology, human agricultural practices, or sheer stochastic chance. It proves the virus is smoldering in the background across a wide geographic range, ready to ignite when conditions align. Part 5. The Fight for a Cure. The Experimental Arsenal. There is no licensed vaccine or specific antiviral for Nipah virus. Treatment is purely supportive, managing fever, seizures, intracranial pressure, and providing mechanical ventilation. It's a desperate battle against the body's own collapse. However, on the cutting edge, there is fragile hope. Monoclonal antibody M102.4. This is the most promising candidate. It's a human monoclonal antibody that binds to Nipah G glycoprotein, blocking its ability to attach to human cells. It has been used on a compassionate use basis in Australia and was deployed during the Kerala outbreaks. It appears safe and may be effective if given very early. Remdesivir, this broad-spectrum antiviral developed for Ebola and used for COVID-19, has shown efficacy in animal models against Nipah. Its use in humans remains experimental. Vaccine candidates. Several are in early-stage trials using platforms like viral vectors, ChAdOx1, a platform used in some COVID-19 vaccines, and messenger RNA. The challenge is conducting trials for a sporadic, high-fatality disease. The real-world response is a public health siege, establishing containment zones, rigorous contact tracing, over 700 in Kerala, 180 in West Bengal, enforcing masking, and shutting down potential sources like date palm sap collection. It's a race against a virus that moves faster than our medical science. The Nipah outbreaks of 2026 are not random acts of nature. They are the predictable, deadly consequence of a collision between a persistent bat-borne virus and an expanding human frontier. Each outbreak is a live fire drill for a potential pandemic caused by a pathogen far deadlier than COVID-19. It exposes the stark gaps in our medical defenses while showcasing the heroic, on-the-ground public health efforts to contain the uncontainable. Nipah virus is a brutal teacher. It reminds us that our health is inextricably linked to the health of our ecosystems, and that our greatest vulnerabilities are often hidden in the treetops, waiting for the right moment to descend. If this investigation into one of the planet's most frightening pathogens gave you a new perspective on pandemic threats, please give this video a thumbs up. This is a story of science on the knife's edge. Share this video. Global awareness is a form of preparedness. Subscribe to Health Inside, Anatomy and Science, and hit the bell. We track the emerging pathogens that define the frontiers of global health security. Respect the spillover, fund the research, support the responders.